Hi everyone. We're going to go ahead and do a quick review of stoichiometry. It's been a while since we've done these kinds of problems together, so I wanted to make sure we all remember the steps and the strategies to solving these stoichiometry problems, especially the long ones. So first of all, we're going to go ahead and balance this equation that we have on the top. We're going to do 1, 2, and 3-step problems using this equation. So the first thing we're going to take a look at is our chlorine. We have 2 chlorines in our reactants and 3 in our products. In order to balance those chlorines out, we're going to need a least common multiple, which would be 6. So we're going to end up with 2 times 3 equals 6, and 3 times 2 equals 6 for our chlorines. So we have 6 chlorine in our reactants, 6 in our products. Now let's take a look at our iron. We've got 2 iron in our products, so we'll need 2 in our reactants. And for magnesium, we have 3 magnesium in our reactants, so we'll need 3 in our products. So go ahead and double check that you've got that balancing correct. Now we're going to take a look at a one-step problem. So you'll see these one-step problems when you're going from moles to moles in a mole ratio, or from grams to moles, or vice versa in a molar mass problem. For both of these, we are just doing one step. So in the example problem we're doing today, we're just going to do a one-step problem from moles to moles. So how many moles of MgCl2, remember to circle what you don't know, are needed to react with 2.04 moles of Fe? So if you look at your mole map, that is a one-step problem, just a mole ratio problem. Okay, that means that we are just going to solve right underneath. Reminder that we put our given information, which is what we've underlined, in our margin. That allows us to do our conversions along the lines and to not run out of space at the end. So in a one-step problem, that doesn't really matter, but in a 3-step problem, that is definitely going to matter. All right, so we're going to go ahead and put our given 2.04 moles of Fe in our numerator. Then we're going to go ahead and take our units that we started with, so moles of Fe, and those units are going to go in our denominator. So even if you're not sure how to start, that's the first step you can always do, is take these units, your given units, and put those in your denominator. Make sure you're not dragging the number with it, because this is supposed to be a conversion, not your given information. Your given stays over here. So in this mole ratio, we're going from moles of iron to moles of something else. Okay, the reason we're doing mole to mole is because it is a mole ratio. In this case, we're going to moles of magnesium chloride because that's what the problem is asking for. So we're going to go ahead and put MgCl2 in our numerator. Now we need to figure out which values are going to go here. So if we take a look at the definition of a mole ratio, it's the ratio of the coefficients in the balanced equation. So if we look at the coefficient for iron, it's 2. If we look at our coefficient for magnesium chloride, it's 3. Now notice that when we solve, we're going to be able to cancel out our moles of Fe units. Those are going to cancel out, and we're going to end up with moles of MgCl2. Notice that I circled our final units, and they match exactly the final units that we circled in the problem. So that checks out. So we're going to go ahead and plug this into our calculator. When you plug it into your calculator, you start with your given information. You multiply times the top, so times 3. You divide by the denominator, divided by 2. So we're going to get 3.06 moles of MgCl2. Make sure you're using these final units, the ones that you were looking for in the problem, and you can go ahead and box your final answer. All right, that is a one-step problem. So that's an example of going from moles to moles. You'll see that kind of problem in your homework. All right, we're also going to take a look at a 2-step problem. So in this example, we're going to be given grams of one substance of FeCl3, and we're going to be trying to get to moles of another substance. So let's go ahead and circle what we don't know, underline what we know. You can immediately go ahead and stick your given in the margin like we always do. Oops, not moles, grams. Make sure you keep those units straight. And now we're going to talk about our two steps that we're going to be solving for here. So if we start with grams, our first step, if you take a look at your mole map, is always going to be that molar mass of whatever substance you're starting with. You always, always, always have to get into moles in order to go from one substance to another. So here we're starting molar mass, and it's going to be the molar mass of FeCl3. So once we've gotten from grams to moles of FeCl3, we can then, if you look at your mole map, our next step would be mole ratio. Notice that in a two-step problem, we're starting to creep into this space a little bit. That's why we need to keep our conversions in line. So we're going to do our molar mass underneath where it says to. We're going to do our mole ratio conversion underneath where we wrote that step out. And here we're going to have our given. So, as always, we're going to take our units and we're going to plug those into our denominator, the units that were given, to make sure we're keeping our units in the right place. All right, in order to find the molar mass of FeCl3, which is what it says right here, we're going to go ahead and look at the periodic table. So if you look at the periodic table, the mass of iron is 55.85, and we only have one iron here. We have 3 chlorines, which means we're going to need to add 3 times the molar mass of chlorine, which is 35.45. We're going to get 162.2 for that molar mass. Remember, the definition of molar mass is how many grams you have in 1 mole of that substance. So anytime you're writing molar mass, the value, the large number that you get with that decimal is going to go with grams, and it's going to be per 1 mole of that specific substance. Notice that if I cover up on both sides, all of these different formulas are the same. We've got FeCl3 in all 3. You have to make sure that those are staying the same. You cannot transfer between 2 different substances when you do a molar mass. All right, now we're on to our mole ratio. So if we take our units here, we're now canceled out our grams units. We're in moles of FeCl3. We're going to go ahead and post. Here we go. So we've got moles of FeCl3 in our denominator now. Notice that those units will cancel out eventually, which is great because we're trying to get to moles of something else. And so now we need to get to those moles of something else in this mole ratio. So moles of MgCl2. This is the mole ratio, the mole to mole ratio that we are looking for. Remember when we talked about up here, we talked about how a mole ratio is the ratio of the coefficients. So let's go ahead and look at the coefficients for FeCl3 and MgCl2 up in the equation. So if we look for FeCl3, right here, our coefficient is 2. And when we look and see MgCl2, our coefficient is 3. All right, so now that we've done both of these steps, we know that our grams of FeCl3 are canceling, moles of FeCl3 are canceling. We're going to end up with moles of MgCl2. Checks out because that's what we circled in our problem. So let's go ahead and solve. All right, we're going to plug this into our calculator, starting with our given information times our numerator. You don't actually have to multiply times the numerator if it's a 1. Oops, but we're going to show that anyway. And then you're going to divide by 162.2 times 3 divided by 2. All right, so we get this value here. We're going to go ahead and check our sig figs. In our first problem, our sig figs lined up. nicely. There were 3 sig figs in our number given and 3 sig figs in our answer. Not so much here, so we need to figure it out. So we're given a number with 3 sig figs, so let's go ahead and make sure we have 3 sig figs in our answer. So far we don't have any because zeros before non-zero numbers don't count. So now we've got 1, 2, and we need a third. So let's check over here. If we have this 0 here with an 8 after it, we're going to round that up, and that's going to end up with 0.0641, and our final units, moles of MgCO2. Go ahead and box that final answer. All right, that is a 2-step stoichiometry problem. Now for our last kind of problem, our longest problem, we're going to take a look at a 3-step problem. So anytime we're going from grams to grams, we're going to see 3 steps that are needed to solve these problems. So go ahead and underline what you know, circle what you don't know. All right, so we're starting with 39.1 grams of Fe. So anytime we're starting with grams, we automatically know that our first step is to convert to moles. So our first step is going to be the molar mass of Fe. We're going to go from grams to moles of Fe. Our second step, once we're in moles of Fe, of iron, is to get to moles of magnesium using a mole ratio. And our final step is the molar mass to get us from moles to grams of magnesium. All right, so as always, let's put our given in our margin. We're going to put 39.1 grams of iron. I'm going to solve our molar mass here. Solve our mole ratio here. And finally, solve our second molar mass here. Notice that I have my molar mass, my mole ratio, my molar mass underneath where I've written those steps. I'm going to get my final answer at the end. Great. So we're starting with grams of iron. That means we need to convert from grams of iron. Make sure you're eliminating those units. And we're converting to moles of iron using our molar mass. So molar mass, as always, look at the periodic table. The mass of iron on the periodic table is 55.85. And molar mass is always the mass of a specific substance per 1 mole of that substance. So 1 mole needs to go in front of iron. So 1 mole of iron has 55.85 grams. So our units of grams are going to cancel here. We're now in units of moles of iron. So that means now that we're in moles of iron, we need to get to moles of magnesium. So moles of iron need to go down in our denominator so these units can cancel. Remember, as we talked about above, a mole ratio is looking at the coefficients of the balanced equation. So we're trying to get to moles of magnesium. We're going to have those as our units in our numerator. For moles of iron, we look up in our balanced equation. We're going to see that the coefficient is 2. For magnesium, if we look at our balanced equation, the coefficient is 3. So now we can see that our moles of iron will cancel out. Those units are out of the picture now. Now we're in moles of magnesium. So we started in grams of iron. We converted from grams to moles of iron. And now we converted from moles of iron to moles of magnesium. Our final step here is getting to whatever we've circled in our problem. So grams of magnesium is what we're trying to get to. Right now we're in moles, so that's going to be a molar mass problem. We're going to make sure that whatever units are in our numerator are then transferred to our denominator so that those can cancel out. And ultimately, we're trying to get to grams of magnesium. If you look at the periodic table, in magnesium, there are 24.31 grams in 1 mole. Make sure you're including this number, this decimal number, with the grams units, because that's how many grams are in 1 mole of the substance. All right, so now we see that our moles of magnesium are going to cancel. We're going to end up with units of grams of magnesium, which is exactly what we circled in our original problem. Yay, we're almost there. Now we need to plug all of this into our calculator. So we're going to do 39.1 times 1. Again, you don't technically need to do that step. Divided by 55.85 times 3, divided by 2, times 24.31, divided by 1. All right. So we end up with this long number again. So we're going to go ahead and take a look at our sig figs in our problem. We have 3 sig figs in this number, which means our answer needs 3 sig figs. Make sure you're looking at the problem and not at the masses from the periodic table. So our final answer, we're going to have 25.5. And our final units are circled, grams of magnesium. All right, so that just about concludes our stoichiometry review. If at any point you're struggling on this homework, make sure you are reaching out, you're asking questions, and you're continuing to watch this video to help you. All right, good luck on your homework.